Okay, hello, welcome to another section in further maths today. Now, our topic for this moment will be on modeling. Now, I know we're familiar with the word modeling. This is not the first time we're hearing this word modeling. But the question is, what is modeling? Now, from what we have here, so modeling is the application of mathematics into real life. I know you'll be wondering, how can one apply math into real life? Now, modeling is talking about those points. That's how can we apply our Pythagoras theorem, our knowledge of geometry, our knowledge of statistics, and so on. Now, how can we apply Pythagoras theorem into solving our day-to-day problems? How can we apply our knowledge of geometry into seeing that some of the things we see around us is being calculated in its appropriate terms? How to apply our normal way of statistics of evaluating, collection, systematically creating room for ideas in real life. So mathematics and further maths, as we all know, is not just a go down writing stuff. We have to apply the knowledge that is being gotten from it into our success in real life. So by the application of this, the process of you applying the mathematical concept into solving real life problem is called modeling. Now, uses of modeling in mathematics. Modeling can be used in the industry. I'll tell you how. It can be used by consumers. It can be used by the government. It can as well be used by, will I say, the health industry. Weather forecast. We also have okay, let's go. It can also be used in educational, environment, and so on. There are so many places we can apply modeling. Now, let me take, for example, let me talk about the weather forecast, how we can apply modeling. Now, when you make use of weather forecast, you're talking about, it's called, we can use a time series analysis. So let me say, for instance, in the morning on 1st of June 2015, it rained. Now we can also see that on the 1st of June 2016, it also rained. 1st of June 2017, it rained. Now 1st of June 2018, it rained. Same thing, 1st of June 2019, it rained. The same thing in 2020, it rained. Now it will be clear for you to predict that on the first day of June 2021, it will rain. Now you are using these past experiences in creating an analysis. Now this is a mathematical application. You've discovered that for 1, 2, 3, 4, 5, 6, for the past 6 years, it has been raining on the 1st of June. Now, if being asked, among all the days of the year, choose one year that there is a high tendency of rain, of us having a great shower of rain, I know definitely the first thing that will come to your mind is 1st of June 2021. Because analysis has shown that for the past years, we've seen so much rain on the 1st of June in each day of the year. So with this, it will be right for you to also predict that on a time like this, it's going to be raining in all over parts of the world. So the same thing is applicable to modeling. So modeling, the government can also apply that in trying to ascertain the population growth of a particular country, like creating an analysis. Maybe if you had in 2020, you had, okay, let me say the population of a country is 5 million. Then in 2015, then in 2016, you have 10 million, 2017, 15 million, 2018, they discovered that they have 25 million, 2019, 30 million, 2020, 30. It will be right for the government to predict that in 2021, the population of a country can be 40 or 45 million based on the analysis that they have in the previous time. Now, what are the areas mostly used for mathematical modeling? We have number one, just like I stated here, predicting population. Population, that's number one. It can be used as in the financial sector. In the financial sector. Yes, it can also be applied during war and conflict. War and conflict. Modeling can also use to predict or to ascertain the spread of disease or a pandemic, among others, etc. So there are so many ways we can use modeling to that we can apply modeling in real life. So now let's ask, now what is a model? What is a model itself? You know, we've been talking about modeling. Modeling is a process. Why model itself is a concept. I think that's a major difference between a modeling and model. Modeling is a process, while model itself is a concept. Now, what is a model? A model in mathematics is a concept. Yes, just like what I stated earlier, it's a concept that represents a real life situation. This is developed to help in the understanding of a physical phenomena, such as to make observations, collections of data, and to carry out experiments. That is one about modeling. Now, let's say example of mathematical model. You know, we've been talking about some things. Let's say, for example, we have okay, let me go with the Malthusian population growth theorem. Malthusian population growth model, and it states that the food production grows in arithmetic progression, while the population increases in a geometric progression. So this is a model that was created to ascertain the relationship between consumption and population. So Malthusian did justice to this by creating this model to dictate the relationship between the increase in food and increase in the human population. We have so many. We can even create the model. Will I say a model of a household financial budget. A household financial budget is another good model that can be created in order to help the entire people or family in ascertaining the amount of food or the cost of living or the cost that is used in running the day-to-day activities that takes place in the house. So there are a series of models that have been created by so many, but we have a model was also created by Dalton and Newton, Isaac Newton. We have John Dalton. We have that was being created by Demings. We have other theorems too, and there's above among others. So I would like us to finally take a look at variables. Now, when we talk about variables, mathematically, we have variables, which is 1, and we also have constants. Now, what's the difference between a variable and a constant? Now, a variable happens to be any concept that is being subjected to, that is free, that can change from one particular state to another. While constant talks about a parameter that cannot be influenced or that remains the same throughout the process, while a variable talks about parameters that can assume different values, and constant assumes only a particular value. And we have so many types of variables. Will I say number 1? Have the output variables. We have 2. We have the input variables. We have random variables. Number 4, we have exogenous variables, and we have number 5, we have decision state variables. Now, among these variables, I know you'll be expecting us to write something like, let me say the independent variable and the dependent variable. Now, but let's take a look at this: the output variables, the input variables, the random variables, the exogenous variables, and the decision variables. We also have the independent variable and the dependent variable. Now, in each analysis, a variable assumes more than one particular parameter. So let's take, for instance, the independent variable. Now, the independent variable is a variable that acts or assumes the position of a course to a model, while the dependent variable acts as the effect. So the independent variable is the cause, while dependent variable is the effect. Now, if we have an equation like this, b naught plus b1 then x, you can see that our y is what we are looking for. So that is to say our y serves as a what? The effect or the response. Y, our value of x here, serves as a cause. So a change in y will always have an effect to what? To the value of y. A change in x will affect the value of y. So my increase in x might inflect the rate of y positively or negatively, and this serves as a constant term, and this constant term remained unchanged throughout the experiment. So with this, you understand that when we are talking about variables, they might assume different parameters in as much as the model is being created, but when it comes to constants are those parameters that assumes only a state throughout the course. And I think we've done justice to this. So I would like you to take this test that will be coming up in your screen, and do well to use the lesson notes on this platform for a better information on the topic we've discussed. Feel free to drop your questions on the comment section, and hopefully it will be attended to. Thank you.